Right, can you hear me all right? Is my voice clear? Let me get my setup ready. So go to right, so today we're going to continue trying the source code for the project for the paper PIFu, which is this is a very important paper on 3D deep learning, and it's used by, it's cited by other papers, more recent papers like PIFu is from the same author, but it's a paper that followed this paper. And then you have, of course, Google Forum and others papers. Yeah. So the thing about PIFu is the innovation here is that they introduce pixel-aligned implicit functions for representing 3D surface. Yeah. Okay. So in the last live stream, I tried the demo, and I was able to create a 3D model. I've saved the notebook somewhere, so I'm going to go to Google Colab, and I'm going to just go back to the notebook that we had before. Okay. So we have, there was the paper copy. Pardon me. So I had to downgrade the version of Pytorch. Okay. Let me just run this quickly. So we'll try to run this for the time being. We'll try to do as much as possible inside Google Colab. Okay. And we have here too. So we have to install the version 1.4.0. We don't need to worry about Pytorch 3D. We're not going to use it. It's actually used for creating an MP4 in this case. So it's not really important for us. I'm going to go and open the instructions for the training. So today we're going to try and train the model. So just to highlight an important thing. First of all, I haven't tried to do the training before, so I don't know if this is going to work or not. And this is why I'm trying it in a live stream, so I know what's going to, I find out what are the problems that we might encounter, that you might encounter if you try this, and hopefully save you some time. So it's talking about here some things that we need for training. It's also telling us that some if we have out-of-date NVIDIA drivers can cause errors. And then there's some instructions on how to do the demo in Windows. And okay, this is for demo mainly. So the paper, the researchers, so the paper used a lot of training data. They couldn't release it because it's commercial data. So 3D models actually that were purchased from a website, but they did provide a couple of models that are free of charge, and you can use this as basically the idea is to train this model with the very limited data set. That in this way you basically we learn how to train a model, and then it's up to us to get like a data set. Yeah. Right, so let's see. So I've already, okay, so we have everything ready on this side. But no, I can't run that section. So I need to install Pytorch Vision. It's already, so I also need to install that. Okay. So my sound hopefully is okay, right? So Pytorch Vision. Let's see what we need to do for the training. Yeah. Seems like we have to install some additional packages. We need to download the model. So I'm going to try and download the model and see how big it is. Probably better to do it from inside Google Cloud. It's actually quite big. But let's just take a look at it and see what it contains. We have a bunch of 3D objects. Okay, so we have the 3D model of from a website, which is I think that website basically provides a model free of charge, just for you to see how it looks like. So this seems to be a good quality model in one of the poses. And this one is the same model, I think, without a texture. We have same model. The model now is 100K. I don't know what that is. 100K what? 30K and 100K. I don't know what that is. Right. So, okay, so there is a bunch of files here. There's even a voucher. Don't know. That's not used for training, I think. Right, and then we have what the texture is inside this folder. Excuse me. All right, so everything is in here. So what we can do, we can just copy the link. Yeah. So I'm going to add a new section here. We don't need to visualize the reconstruction because in the last live stream we found another way to see the model without needing to visualize anything. We can actually install MeshLab, or if you have, I don't think Blender works very well because I don't think it supports per vertex color, which is what yeah, this is how the texture is being applied to the model in the PIFu. Delete this. Yeah, and let's add a new cell. Training. See if we can actually do any training directly on Google Cloud. and I have no idea whether this is going to work or not. It's the first time I'm doing it. No, this is not the right thing to do. Curl. I think -O or something. And then we can download it. See if it's don't know which directory this was downloaded to. So content PIFu, so it's here. Okay, so the zip file is here. So, well, when we figure out, okay, the next step, then we'll know where to put this. So let me just go to the next step now. So the next step says we need to set up PMBring. Okay, and we need to create a folder called, so we need to call this, create this folder. Okay. Be content PIFu. Yeah, so creating that folder, and then we're going to unzip the contents of that zip file inside this folder. Have a folder now with the contents of the zip file as it was requested here. Okay, and now what we need to do is to run a Python command. Let's see what it's saying. So we need to run a script. To compute the spherical harmonics coefficients for pre-computed radiance transfer. In a nutshell, PRT is used to account for accurate light transport, including ambient occlusion without compromising online rendering time, which significantly improves the photorealism compared with the common spherical harmonics rendering using surface normals. So we need to apply this Python script once for each object file. Okay. Let's see. We have a few. We have like, no, we have two. So we have a copy path, and I'm going to run some code. At this stage, let's see what happens with the code, whether it works or not. Okay. We are running code inside here. This is doing the conversion as it was explained. So let's run this and see what happens. No module named TriMesh. Okay, seems like we have to install some prerequisites, and that's probably what's actually describing somewhere it's describing what we need. These are prerequisites. They might actually be specified here. They normally are in the requirements.txt. So it's also here. Okay, so let's try and install the prerequisites directly from the requirements.txt. I forgot the exact syntax. Let me see. Pip install requirements.txt. Pip install missing -r requirements. So this is an easy way to just install all the libraries here without having to do one by one. Sometimes when okay, right now we are lucky it's installing everything without error, but sometimes it might be a bad idea to do everything at once because then you get lots of errors. But it seems like all the dependencies are being installed without any issue, which is awesome. And it's, as you can see, it's actually uninstalling some libraries and installing a different version of it, depending on what it's asking for. Now it's telling us might be in trouble because of all the version incompatibilities. But let's hope for the best. This is where normally Python goes wrong. If we don't use an environment or something that is independent, sometimes you get this version hell. No module named Python. Okay, I need to run the first cell. I need to be in the folder. Let's find out. Let's run this again and hope for the best. And we're getting an error. Not a directory. Oh, I see. Maybe I didn't give the right path, so maybe I just have to give the path of the directory. No model named R3. It's not in the requirements.txt, right? So let me see. So try mesh has some dependencies. Okay, let me see to resolve this. Well, I don't know which version of R3 to install. That's why I was checking. There's not much information about this error. Okay, let's just hope for the best. So okay, installed 1.0.0, which is a very maybe it's the only version available. I don't know. Right. So it's doing something now. I think it said it might take a while to complete this. So let's find out. Taking a bit of time. Let's see how. Okay, I'm trying to use a GPU. Said it would be very slow if we didn't install something very important. It's not this section. Let's find out. Taking a long time, it doesn't tell me. I'm going to go into the issues while this is running. Also find out if anyone's complaining how slow that command is. Always a good thing to check the issues. Okay, so first thing I find is problem encountered with data when data generation. We see again an error. For me, it's just hanging. Right? Don't know if it's I don't know if it's stuck or not. So I'm running Sure, you can ask questions. Yes, go. I'm just waiting for this to complete, so it's a good time to ask any questions you might have. See the code of this as well in the meantime, just to check what's trying to do. There's no... Oh, it's just finished. Finished or cancelled? Okay, I think it's executed. But it's a bit unclear whether it's actually completed successfully or not. Let's see what's coming next. So we've done the data generation. Now we have to run this script here. And what it's trying to do is going to create some extra folders: geo, render, mask, param, UV render, UV mask, UV normal. Headless service, yeah, this is a headless service, so I think we need to use the -e flag. All right, to answer your question, Jim, why do I need to train my own data? The reason you would need to use your own data is because most times when you use a model like PIFu out of the box, the results are not very, are probably not going to make you very happy, right? And also quite often the use case that you have is completely different from what the pre-trained model provides. And the pre-trained model often is also not trained to the same kind of level of like, it's from a research project at the end of the day, right? So they use their own training data, which means their model works for the use case they had in mind. So if you try this model, you probably have another use case in mind. And if you look at my previous live stream where I actually tried the demo of PIFu, you'll see that, for example, I tried with my own picture and the 3D model itself was quite poor. But anyway, I think the main reason is it's important to know how you train this model, because then you can also change the type of object that you want to render to 3D, right? So it could be, instead of a person, you can try to, well, I had someone ask me before, they wanted to do scans of furniture, right? And they wanted to convert that to a 3D model, right? So you might want to use PIFu for scanning furniture, right? In converting it to 3D. But in that case, you need to use training data, which is, you need to use furniture as your training data, right? Not people. But I've already downloaded the model. You can also download that. So if you just want to try it, there's nothing wrong with that. You can, it will work to a certain extent. And I'm actually going to do, PIFu is already fairly old. Yeah, to train, you need to have a lot of 3D models, right? And to get 3D models is actually quite expensive, right? Because if you look at where this 3D model is coming from, Rent the People, I think. It's a website. You can see how expensive it is. So one model is like, here you can see like £34, which is about what, $50. Hi there. If you for the PIFu research paper, I think they used almost like 300 models. Okay, and it is still very little data. So in order for them to make it work, they had to use augmentation, right? They had to make some artificial changes to the models so that they can increase the variety of the data. So it's quite expensive. But yeah, that's the key. And there's a lot of research now to try and basically do away without having to have 3D models for your training data. So instead of using 3D models, for example, NVIDIA has a new paper where they show you how they use photos, 2D photos, as a way to generate 3D models, which is crazy. So they use the training data only with photos that are generated by a GAN that is able to actually, anyway, I'll go uncover that paper very soon actually. So anyway, all right, so I need to just complete the next step before, so I have to run this code. Okay, what do I need to do here? So I need to copy this folder name. So what I'm trying to do here, I'm just trying to figure out whether the training pipeline here works, which will, so that's why I'm just following the steps they have. And okay, I already can see some errors. So it's asking for another model, which was not in the requirements. So I'm going to add that here. Hi, Prof. Maths. Nice to meet you. Okay, so let me install this. So far, I think I've been very lucky with all the dependencies. Okay, so now it's giving me another error. It's saying that it doesn't recognize this argument because I need to comment this out in. So I need the -e flag because it's a headless GPU. And PRT file does not exist. Okay, path to training data. Wait, hang on. I thought this was the training data. Okay, I need to go back to the instructions and find out. Path to training data. The specified data path. I'm not sure. Val.txt. So let's see what that is. Refresh. We have PMBRI. I think I need to install that at some point. Under the specified data path. That's the one. The same as this one. And then minus, oh, this is output. Okay. Okay, I got it. It's looking for bounce. It's saying here. Don't know what the bounce is for. Have here I'm just going to call it. Just going to make up the directive for now, and it's mentioning there is no PRT file. There's a bounce directory here. Wondering if this Python here actually worked. So I need to check this. What's the directory here? Okay, so this is actually supposed to create a bounce file. So I know for sure now that this didn't run properly because it doesn't have that file. And this is the opportunity. If you have any questions, let me know. I'll answer the questions while I wait for this to execute. To take a while. In the meantime, if there's no questions, I can also go through the code. There's some interesting code in here. data. You can also go to the paper and on the paper as well. So there's like two methods here that are important for the training. So two files, right? Train shape and train color. Okay, and if I show you the paper, there's a diagram that we should definitely look at to understand how the training works. This diagram here, okay. I've written an article about Forum, but Forum is actually another model from Google. It's but it's a paper that is actually copying this paper, let's put it that way, but it's improving it at the same time. And I've created an an explanation that kind of explains how the model actually works, and it's applicable both to the PIFu paper and also to Forum itself. But of course there are differences, and I can explain what the differences are. Okay. Not this one. This one. Okay. So okay, in PIFu, right, we actually have to create a mask, and in the previous live stream I actually showed you how I created that mask in Photoshop. The idea of the mask is just to make sure that we know where the subject is that we want to convert into 3D, okay? So you have it here. Then we run feature extraction, right? So you can see here we have an image encoder, which is also called a feature extractor, right? And this image encoder basically is applied to the image, and it gives you like hundreds of features. In the case of Forum, it's actually quite a lot. I think the Forum will calculate 256 features, which are basically, you can think of it as 256 copies of the original image, but with filters applied on top, like you see here. And the idea is that the AI model is trying to figure out, for example, like the features of the human body in this case, like where are the arms, where are the eyes. So each filter, each feature is the result of applying a filter which is looking for something very particular. Because this is a neural network, right? We don't really know what's looking for. It's like a black box. But if you've studied like computer vision, you know that the very basic of, for example, trying to do how do I call it? There's some algorithms that there's like very simple filters that you can apply, like a Gaussian blur, or you can do vertical line detection or horizontal line detection, and that's what basically the image encoder or the feature extractor is doing here. Okay, so PIFu has two of these, one for the geometry. Okay, it's trying to figure out the geometry. That's the first image encoder, and the second one is trying to figure out the texture. Okay, and out of that, it will basically, using these two image encoders. Okay, this is where it gets a little bit more interesting, right? So how do you get from 2D to 3D, right? So once we've calculated the feature maps, right, which are the collection of filters that we have here, right? In this case, 256. I think for PIFu might be less than that. I think, I don't know how many features it calculates, but it should be less than 256. Anyway, before I continue, let me just check if this finished. Okay, this has completed. Let's see if the file is there. Hopefully it is. Okay. I think that there is a problem. The file is not being generated. Oh, I see. There's something here that tells me maybe this is... I wonder if this Python script is even allowed to complete, because it looks like it was killed. I don't know what this is. I think Google Colab has just killed my script. So I'm not sure if I'm actually able to complete this in Google Colab. I might have to swap. I might have to swap to my machine, but then I don't know if I have time for that. Let's see. So I have half an hour. Okay, let me see. So it didn't run. So if I want to install this in my Anaconda environment, my only concern is that because I'm using my GPU, it's going to kill my machine. I should try, right? So I wasn't planning to set up my local environment, but then let's just see if I can create. Let's call it PIFu and I need to be very specific about versions, right? I want to know what version of Python. So Python 3 is not very specific. Can be. I'm going to assume it's Python 3.7. Okay. because that's what Google Colab seems to be running as well. Let's see. So let's see, Python version 3.7. Okay, so I'm going to try and install that in my, or just use Python version 3.7. The closest I have. Okay. I hope I'm lucky with this setup because my environment has a GPU, but it's nothing. My GPU is not as powerful as the one in Google Colab. And second of all, I'm already using the GPU for broadcasting this because I'm using NVIDIA Broadcast, which is awesome. I don't need a green screen or even, yeah, it helps me also filter out noises. Okay, let's do open terminal so I can install. Oh, the nice thing about using Anaconda is that I can just use Conda to install the dependencies. So I'm going to find Conda install Pytorch 1. I think it's 1.4. Conda. It's a CUDA version. That's the only reason I might not be able to use Pytorch 1.4. Anyway, I only want to run the training. Okay. I'll just run it and see what happens. Windows 10. Well, I'm a little bit in trouble because I need to use Pytorch 1.4, at least for inferencing. Well, I can try. I'm just going to run a later version and see what happens. This is where I'm learning something new. Because, okay, 1.4, I can't install 1.4 because my CUDA version is 11.2 and I know my GPU won't work with anything below 11.2. So I need to go to the earliest, so previous. Okay, so I need to see what are the previous versions of CUDA closest to 1.4, which support CUDA 11.2 at least. So I can see 1.10 is probably like yeah, I'll try to use 1.10. Oh, this is not even the version of. Let's see. So if I go into a terminal, I hope you can see that. So I can try and run this, and I can install Pytorch. And I'm hoping 1.10 is okay for the experiment I'm doing. Anyway, I was saying that for the way so basically the neural PIFu, so for each point in our features, right? Sorry, PIFu uses a surface, a space, which is this space here. So for each point in this space, then we project this point into 2D, and then we take a copy of the pixels for that point in that given position, right? So in this case, if we have 256 features, we'll take like a copy of 256 pixels, and we associate that to the point. And that's why it's called pixel-aligned. That's why the paper says that, pixel-aligned. And then this is going to be used later on for the geometry and the texture. Anyway, going back to Conda. Let's see. So I need to try and run the installation of Pytorch, and then I should be able to run the same Python code I had before. So I'm kind of, you know, I actually expected to be suffering a little bit with the versions of packages and things not working. I was expecting something not to work, to be honest, because this paper is from 2019. It was on it was developed on CUDA version, on Pytorch version 1.4.0. Yeah. And yeah, it's a reality, right? So in order to get this code to work, I probably will have to spend more than one live stream on it. And probably it would be most of the time spent trying to figure out which versions of packages. And then at some point I'll find what is the minimum baseline for running all this code. And there might be some changes I have to do in the code to adapt to the new APIs. It's definitely worth doing it if you are looking to use your own data set and train the model. If you're just trying to see a demo of how it works, it's actually very easy. You can see my previous live stream and you'll see how it works. The results are not great, but this paper is really important because the concept of implicit functions is something that is very memory efficient, and it really helps in 3D deep learning because, you know, in terms of memory requirements, when you're doing deep learning, right, with 3D models, the memory is the thing that is the main constraint. Still installing Pytorch. So if you have any questions while I'm waiting for packages to be installed there, feel free to ask in the chat. I'm checking it. I'm trying Pytorch 1.10 and hope I hope it's going to be okay with this version. For Anaconda, it's actually quite useful because with Anaconda, I can create different, let's call it projects or different environments, and I can install different versions I need for everything without basically it's great because these versions, right, of all the packages I install inside the PIF environment, they are independent from the versions that I install in other projects I've worked on. For instance, Kaolin is something else from NVIDIA. It has a completely different version of Pytorch and yeah, or even Python, right? And I don't have to worry about messing up that environment just because I'm trying something new for PIF. Yeah, so it's definitely worth having. Next, so let's see how it's okay. It's still installing. Fingers crossed that it's going to. I still need to install. What else? I need to install the requirements that we had also to install here. Let's copy this. The nice thing about Anaconda as well is you don't just have to use the conda command to install things. You can also use pip. So if something is not available as a conda package, it's okay. You can still install it as pip. Okay, it's still running. Still running. Okay, so hopefully all of this works, and I'm just going to install now the requirements. So pip install requirements.txt -r, of course. Okay, I'm in the wrong directory, so I need to go. Okay, I need to open. Okay, another thing I can do easily with Anaconda, I can install a Jupyter Lab. I'm going to need one. And I have to copy the notebook as well, and I need to download the source code. I'm going to pick a folder for this. And I can just launch. I can launch now Jupyter Lab. It's in a new environment. I have some notebooks here also from my previous YouTube videos. I'm going to close all of this, don't need it. So let me just open. For some reason it disconnected. Try and reload. What happened there? Let's start again. Seems like it crashed. It's crashing. Okay, so maybe having bad luck. I'm going to try a simple Jupyter notebook and hope that doesn't fail. Launch that. So documents, YouTube. Okay, so I'm going to download the source code. Here. It's interactive as Jupyter Lab, which is a shame. So I need to rename it. PIFu. So new. Okay, so I have a notebook now, and I can try and do a git clone and see if that runs from inside here. So it's cloning the project. It's doing that. I can copy more things. cd PIFu. So it's already downloaded everything. So I'm just going to copy everything. So let's, well, this is for downloading the trained model. I don't need that. I think I already have the dependencies, so I'm not going to install any of that. I'm going to check the version of Pytorch that I have, make sure that's actually being detected. Okay, it's 1.10, which might give me some grief, but you know, we have no choice there. And what happened to the requirements? Okay, yeah, so I can install it from here. So pip install. Let's try and install the requirements. Okay, couldn't find it. Is it because it's not there? Let me find out. So we have, it's going to be, yeah, it's there. Unless I'm not in the directory, I think I am. See if, because I'm on a Windows, so okay. So pwd. Okay, this is actually not going to work because I'm not on Linux. So I need to just hope that this works. Okay, I am there. So cd p. Okay, now I'm there. Okay, so it should work. It should install. At least try to install something. Okay, there's no. Okay, because we don't have Pytorch 1.4, I probably need to review the requirements. So this is another. Okay, I don't want torch. These two I can't have them here because it would conflict with my Pytorch version. So I need to run this. Let's just run this out again. Nice. There's some permission errors. Could not install packages. Don't know which one. Okay, let's find out. I'm going to the next step and see where it fails, so I know for sure what's going to fail. I also had some errors here, so it's no different. Still installing the second one. Oh, another error. So I have a problem with, I think the second package didn't install. This is not going to be easy to fix. Completely messed up. All right, so let me see what. I don't know if we need this or not, but it looks like we do need it because. Okay, let's see what Google tells us about this error. Kind of looks scary, to be fair. OpenX. Okay, so Stack Overflow to my rescue. Oh, hang on, but are we actually even talking about the same library? OpenEXR. This is PyEXR. Win. Okay, let's try this. Might be. This is our only hope. Pip install pipwin. I never heard of this utility. It's the first time. I could try and run this directly in Linux because I have the Linux environment. That might be something I'll do on another occasion. Not today, but okay. Let's see if I can just do pipwin install PyEXR, so it doesn't have to compile anything. Fingers crossed. Pipwin install. Okay. So we have PyEXR. It's running still, which is a good sign. Okay, not found. Awesome. Pipwin, refresh. I was searching for something else. Oh, maybe it's OpenEXR actually. Okay, let me just install this. And then maybe the other PyXR will install after, if I can install it like this with pipwin. Okay, so it was able to install OpenEXR, and let me try and install again PyXR. Oh, it worked. To be honest, when I saw this error, I thought it was it. That was the end of my, you know. I didn't think I could recover from this error because it looks so ugly. But anyway, it seems like there was this worked. Okay, so the next step, right? Okay, I have the libraries I need. I need to download this model. I think I already downloaded it actually. So I just need to place the model in the right folder. So I'm going to just get it from downloads. So I'm just going into a private window. Downloads, and I'm going to place it here. Okay, and I'm going to extract it. Okay, so the folder is this one, so I'm going to copy the path. Okay, need to. I'm not in the right place. Okay, so this is the right place. PIFu. So this is a folder. No, this is a zip file. The actual folder is here. Python. So I'm going to be executing the command that was failing in Google Colab, and I'm hoping it works in Windows. But you know. Already inside the PIFu folder, so I should be able to just run like this. Yeah, so let's find out. Fingers crossed it will just run. No module name TrimMesh. Okay, I need to install TrimMesh as well. Pip. I thought I installed it, to be honest. Pretty sure I did. Maybe I need to restart the kernel so it picks it up. Quite often so I need to make sure that the folder is correct. I'm in the right folder. Okay, the module is there. Oh, there's another module that's missing. It's running now. So let's see if my computer If my stream stops all of a sudden, it's because this script has killed my computer. Yeah. So I don't know if it's going to cause any problems or not. But just bear that in mind. But so far, it seems under control. It has already created a bounce folder. It's supposed to create the file here. So fingers crossed it should work on my computer. I don't have an RTX 3090, I have an RTX 3070 and it's already being heavily used for this stream. I'm thinking of getting since the GPU prices are going down so much, I'm actually thinking of getting a second GPU. Maybe a RTX 3090 Ti or something like that. Yeah, so I was looking at some of the MSRP prices. So it's supposed to be, so the 3090 Ti is supposed to cost what, $2,500 US, but apparently you can get it for like 1,300. Still too expensive, I would say. But then the new 4090 is coming out as well, right? That should be like a monster. Yeah. So let's see the RTX. This is just running. It's doing a lot of heavy work, I hope. The thing is, it doesn't give me any clue of what's going on. But if you look at the code, it's doing a lot of heavy mathematics, let's put it that way. I can. If you look here. Oh, it's already disconnected me. Click reconnect. You can see PIFu, the code. So PRTUTL is the class I'm trying to execute, and you can see here it's doing a lot of NumPy operations, generating random numbers, calculating cosines, arccosines, and yeah, I'm not 100% sure what it's supposed to be doing here, but it could have some debug saying, okay, I'm actually doing something and not just hanging there. If all works, it should create this file here. I'm trying all of this so you don't have to try it yourself, because it's a lot of pain to try and get all these Python versions and Python libraries to work together. Right now it's doing something, I have no idea what it is doing. But you know what, maybe I could just look at my activity, my GPU. I think see what's should be very. I think you can do it here. Right? There's a utility that actually shows you the the GPU memory. Okay, so you can see I have an NVIDIA RTX 3070, and you can see the GPU is doing something, but it's not right. It's not very busy right now. 25% being used. I wonder if this code is even using the GPU. You might be just using the CPU. But the CPU is also quite not like that busy as well. Memory is high. Yeah, I don't see anything like too heavy being done here. Yeah, so I think if this doesn't work, then I will just give up at this point, but I will try to do another live stream, and whatever errors I get, I will try to solve it in the next live stream. But I'm hoping this just works. Anyway, I could go back to the paper if anyone is interested. So the way that implicit function works, okay, is that once we calculate the feature map and then we project all the points in a space to that, basically once we associate each point in this surface, in this space, in this space to a point in the feature map, right? Then we get like this pixel-aligned vector for each point. And then at that point, we apply an implicit function f, which is the PIFu function, which basically says for each point whether it's in or out of the surface of the 3D model, right? And once we have that calculated for all the points in the space, then we use the Martian cubes algorithm, which is a very famous algorithm in computer graphics, and we use that algorithm to reconstruct create the mesh, which is for the geometry, right? And then for the texture, there's a similar algorithm apply, but it's instead of getting positions of vertices, we get colors. Still running. So for Google Forum, which is a more recent paper from Google, they were heavily inspired by PIFu, okay? But they made some like improvements, right? So instead of just calculating in or out, which is called the probability field, they calculate distances, right? So for each point, so in Google Forum, not only they know whether it's in or outside the surface, which is the surface is basically the person, yeah, but also it calculates the distance of that point to the nearest point in the surface. Okay, and then they apply that to the geometry and to the texture, and also they can calculate the lighting, so they can actually extract the lighting, the light source from the image, right? And this is actually quite groundbreaking, right? Because then they are able to you know, you can just use the 3D model, apply other types of lighting and into it, and it's really good. But for whatever reason, Google decided not to publish the source code. But you know what? If you actually read the forum paper, and then, you know, you could take this source code from PIFu and you could apply, if you understood the paper, you would be able to apply the same algorithms that Google applied and get the same results. So that's why it's actually worthwhile understanding how to generate training data with PIFu, and also looking at the code. It's also worth looking at the Python code and understand how it works, because this is the almost like the core of generating 3D models. It doesn't just apply to people, it applies to, in theory, any type of object can be reconstructed in this way. Still running. My computer is starting to make a lot more noise, so I suspect it's still doing something. The GPU is steady at 20%. Nothing too heavy. CPU is 12%. The only problem I have with this, I think, because this code doesn't have enough debug, so we don't know what's happening, whether it's actually doing anything or it's just stuck somewhere. But anyway, I think I've achieved something in this live stream, which is to at least determine whether this is working out of the box or not. I just suspected, to be honest, they wouldn't be working anymore because it's already, this source code is a bit old. But with a bit of more effort, I'm sure we can get this to work again. Someone tried this 8 days ago. At least we know someone is able to run this. So they've been able to run the training. Someone had a problem. My problem is it doesn't seem to be finishing. It just takes a bit long. That's all it is. Should work. Right, so this is not finished yet. I think I'm going to end the live stream here, and I will try to let this run offline. I need to I think I'm going to do another live stream on this, because I think I haven't gone as far as I could have gone. But yeah, okay, so I figured out that I can't run this on Google Colab because this script is somehow is not able to complete there because it's killed halfway through. I've also already established that this might take a while to complete. I don't know how long it will take, so I don't want to stay here for 2 hours and then this hasn't finished. So I'm going to leave it like a whole afternoon or something, and then I'll have a better idea whether this has a problem or not. Okay, thank you so much for joining the live stream. Just see some spam messages. Remove it. Okay, I'm going to complete this. Yeah, don't forget to click the like button, and yeah, I hope to see you again soon in the next live stream. Happy coding!